remembering some of the basic properties, okay, in terms of properties of exponents. So what we see right now, the first few that are on the board look pretty good, okay? For number one, you're multiplying 6 times 4 to get 24, and then you're doing what to those exponents? Adding. So x squared times x cubed gives you x to the fifth. So the first one is correct. 24 x to the fifth. Excellent. Okay, and two, thank you so much for, remember you have to split these, okay? So that means you have 5 cubed. However, what are you doing here? Multiplying, not adding. So it should be p to the what? 6. So either leave it as 5 cubed, but 5 cubed is pretty simple to simplify, so 125 p to the 6th. Okay, should be your answer. And then for number 3, nice job. You are subtracting. Keep your A's together. So you end up with, which is correct on the board, a to the 7th. But can we have negative exponents? No. If it's in the numerator, where do you make it become positive? Denominator. So then we're going to end up adding. So it's b to the 8th. Excellent. Good. And then number 4 should be straightforward. Anything to the 0 power equals 1. Good. And 4, excellent for number 5, whoever did that on the board. Nice job. You have 7x to the negative 6th. The only thing the exponent is touching is the x. So that's the only piece that goes to the denominator. Okay? If it was in parentheses, 7x to the negative 6, then the whole thing would move. Okay? And now we get into our rational exponents, which are just fractions. Okay, you're still doing the same properties. However, with adding and subtracting, you're going to need something in common. So for number 6, which is also correct on the board, you're multiplying these guys to get 2/4, and then you end up with x to 1/2, which is also correct. Okay. Number 7, what I see on the board is the biggest mistake that I always see. Okay, we cannot cross those out. Okay, those are the same base, just like if it was x. Okay, so we have 9 to the 3/5. Now, 9 in the numerator has an exponent of what? 1. But in order to subtract, what do you need in common with fractions? Denominator. So how would I rewrite this? Nolan? 5/5. Good. And now I'm ready to subtract to get 9 to the 2/5. Okay. All right. So please, please, please make sure we're not crossing out those 9s. Okay. Can't cross them out because they have exponents attached. Okay. Now, if you look at number 8, p to the 2nd is correct. However, 3 should be to what power? 1/3. Again, these are separate. So 3 to the 1/3 and p to the 2nd. Okay. Now we get into rewriting, which both on the board are correct. Okay. This number right here is called the what? Jack? It is the index. Okay. This is the index. That index means your root. Okay. So the 4th root. Okay. That's what it looks like. Now, this whole thing is raised to the 1st. Okay. So it's x to the 1/4. Your index is your denominator. Your exponent is your numerator when you're rewriting. Okay. Same thing as what we see on the board. Denominator is your root. So this is the cube root of r. Can be written this way or what you see on the board. Okay. Now, someone in my other class said, can we, like, say r was a number, can we square r and then take the cube root? Sure, However, you're working backwards. Okay, you're working with a larger number. So technically, when we get to evaluating roots, you want to do what we normally do for square roots, simplifying square roots, do the factor tree, and then square it. Okay, we'll get into that in a little bit. Then we get into simplifying, which is actually right here. Okay, the 4 through to 16 is correct on the board. Okay, when we are simplifying radicals, which we're going to see today, we have our factors. Say we're going through and simplifying a square root, right? However, now the index tells us how many of a kind we need before we take it out. Remember with square roots. For square roots, we were looking for 2 of a kind, right? For every pair, 1 came out. Now, if the index changes, that indicates how many of a kind we need to take out. So 4 of a kind, that's our answer when 2 comes out. Now, 27 to the 1/3 is also written as what? How can I rewrite 1/3? Yep. The cube root of 27. And now I'm looking for 3 of a kind. A lot of these you guys are going to skip right over because you know them like the back of your hand. The cube root of 27, the cube root of 8, the 4 through to 16, 4 through to 256, so on and so forth. You're going to know those numbers like the back of your hand, okay? The other way to do this is to rewrite 27 with a smaller base, okay? So the bases that we use, meaning a base to whatever exponent, 2, 3, 5, 6, 7. Why did I skip over 4? 4 would just become 2, okay? So like 16, yeah, I could use 4 squared, but what's the smaller base? 2 to the 4th, okay? So that's why we kind of skip over 4 a little bit, yeah?
Is it always like 4 of a kind or like 3 of a kind when you do that?
Not all the time.
So is there any other way to like check what the answer is?
So here, if you have 4 of a kind, you take it out, no matter what. Whatever the index says, that way, if you don't have it, then it stays inside.
Oh, okay. Is there also like sometimes when it's like a 3 on top of that?
Which we're going to see today.
Oh, okay.
Yeah, we're going to see all of that today. Great questions and good thinking about, all right, what comes next? This seems simple. What else? There's more. Yep, okay. So another way, when you're having these guys here, the majority of ways that I've seen, if you're given rational form, which this is called, a lot of people will rewrite it in radical form, which is the simplest way to do it, okay? But 27, think of a base. How would I rewrite 27 with a smaller base? Like 2, 3, 6. 3 to what power gives me 27? 3 to what power gives me 27? Yeah. 3 to the 3rd. So, if I wrote it this way, what do I do with the exponents? Yeah. Multiply. So I get 3 over 3, which is 3 to the 1st, which is exactly what I got here. Okay? So we're going to see both of these ways. We're going to get to rewriting with a smaller base when we get to solving, mainly. Okay? But there's multiple ways to solve these. Louise brought up a good point. There's more to this. This is one of the easiest because it's a perfect root. We're going to see ones that aren't so perfect or that have more than one pair that we're taking out or something left over. Then what do we do? Okay? Same concept as our square roots, right? So if you take out your notes, and I just want to see if there's any questions on page 1 of your notes. Was there anything that you wanted to go through, clarify, actually see done on page 1? No? Okay. Page 2. Any numbers that you need clarification or to go through? You all good? Yeah, Liam.
Can you go through I think it's the third one on page 3. It's towards the bottom. It's simplify the first product of your partner.
So on page 3, number 3 at the bottom, okay, you have the same base, which is 5. So we have 5 squared, and then 5 to the 6/7. Well, when I have the same base and I'm dividing, what do I have to do with my exponents? Louise? Because what do you need to do? To subtract. So in order to subtract, we need the same denominator, which would be what? Danielle? 14/7. So since this one is already in fraction form, right? I'm looking at 7 as my common denominator here. So that means I'm multiplying top and bottom by 7. So I have 5, 14/7. Now I'm ready to subtract. Yep. Yep. Okay. All right. Any other questions on page 3? Okay. Page 4. Page 5. Which is the chart, anything like that. I talked about that. And page 6 is where the video stopped. So the video stopped here in terms of evaluating. Okay, in terms of evaluating, so just a little recap to make sure we're all on the same page. Okay, we have 8 to the 4/3. So how would I rewrite that in radical form? Yeah. Okay. So I tend to write it with the parentheses here, so you take care of the root first instead of raising it to the 4th. Okay, so the cube root of 8, which again, just to recap, you're looking for 3 of a kind. So what I just did is prime factorization, getting to the smallest possible numbers I could use. So I have 3 of a kind, which is 2. Then 2 to the 4th is what? 16 as your final answer. Okay, so you want to take care of your radical first, then raise it to the exponent. Okay, it's the easiest way and simplest way. If you did 8 to the 4th, you're just kind of backtracking a little bit. Okay, so since you guys went through, did those 4 practice problems up top, I want you to try to evaluate 1 through 6. Go ahead. All right, number 1, what do we have? Go ahead, Esmond. 27, good. So square root of 9, and then cubed. Square root of 9 is 3. 3 cubed is 27. Excellent. Number 2, Liam.
I got 216.
Perfect. Square root of 36 cubed, 6 cubed is 216. Excellent. How many of you got both of those correct? Good. Yep.
Wait, why we use the 2 for the 9?
It's there. For square root, you hardly see it, but it's there. And it's assumed. I could put a 2 here. Means the same thing.
Oh, like 2. Okay.
It's the square root. Yeah.
Okay, yeah.
It's okay. All right. Number 3. Jack. 1/2. Excellent. Okay. The 4th root of 16 to the negative first. 2 to the negative first. Can't have negative exponents. So we end up with 1/2. Excellent. Okay. How about number 4? Danielle. 16. The cube root of 8 to the 4th. 2 to the 4th is 16. Excellent. Number 5. Rosanna? 32. The sixth root, 64 to the fifth, 32. Excellent. And last but not least, Addison, 7. The square root of 49 equals 7. Good. How many of you got all of those correct? Okay. 1 wrong? Okay. 2 wrong? Okay. Do we know where our mistakes were? Kind of? Or, okay. Any questions on those? All right. So the next part is basically what we're going to see when we get to solving, okay? But if you have your calculators, please take those out. This is short and sweet. It's just showing you how to find some of these that cannot be simplified, okay? That we need a calculator for. I'm going to show you multiple ways. Obviously. Okay. So, the first one is the sixth root of 50. Okay. You could enter as is, or, and I'm going to show you in a minute, or, which I do most of the time, instead of going through the process, I do the rational exponents. Okay. So, from here, you go to math, which is below the alpha key. Okay, number 5 is where you could change the index. Okay, if you press number 5, then type in 6 and then 50. Okay, and then if you hit enter, because we don't know, 6 root of 50 doesn't exist. Besides, it's a decimal, not a perfect root. So it's 1.92. Okay, round to 2 decimal places. You could also type in 6, then math, number 5, and it goes right to the index as well. Okay, and then 50. Or what's another way to write the 6th root of 50? Yep. 50 to the 1/6, and you will get the same answer. Okay, which when it comes to time, you might find that a little bit easier to do. Okay, now if you look at B, have we been able to take and get a solution like a square root of a negative number? We would get I, right? Look what happens when you take a cube root. Okay, so you could either do it the other way or go to math. Number 4 is the cube root, negative 29, and you do get a negative answer. So, if you take an odd root of a negative number, you will get a negative answer. You cannot take an even root of a negative number because you'll get imaginary. So, odd root, negative answer, okay, of a negative number. Then if we try C, this is just getting familiar with where the calculator tools are or how to enter it in terms of solving eventually. Raised to the 1/4. Enter, or you could do the 4th root of that one. In the last one, 341 raised to the 2/5. Okay, give to that. Okay, so again, very just straightforward a little bit using the calculator because we will see this. Okay, we will see this in terms of solving, or say if you get stuck, there's always a way to find it. All right? Okay. So what you see here is a little bit of a recap, but now we're evaluating. Okay, in terms of you have rational exponents, you have some radicals happening here, and we are getting into those radical properties soon. When you see the same base here, okay, the base has an exponent attached, what do we do? What do we need to do? Yeah. You add them, but what do we need to do before we add? common denominator, which would be 4. So we have 81 to the 3/4 times 81 to the what? Negative 2/4. Okay, it's okay. Now we're ready to add. So we have 81 to the 1/4. 1/4 can also be written as what? Yep. The 4th root of 81. Good. The 4th root of 81, which is? Yep. 3. Good. Okay. So here we're just taking our properties and taking it one step further. Okay. Now if you look at B, you have x to the 1/5. How do I rewrite the 5th root of x squared? What's that? Good. X to the 2/5. Now am I ready to add these guys? Okay. What do I get? Yep. X to the 3/5. Good. Okay. Let's look at C. What's happening? What happens to the numerator? Let's start there. Jack? Right. Good. It becomes 1. Then we have 7 to the negative 3/4. Can we have negative exponents? No. To make that positive, where does it go? To the top. And all of you speak at once. 7 to the 3/4. Okay. Now, for D, we have 8x to the 6 to the 1/3. How do I rewrite that as a radical? Nolan? Okay. Okay. So you just did the property 8 to the 1/3 and x squared. Okay. Right. But then from there, how can I rewrite 8 to the 1/3? Which is 2. Okay. So Nolan went this route, which is okay. Okay. The other way is the 1/3, like Nolan said here, is the cube root. Well, since this whole thing is in parentheses, I could write it underneath the radical. Okay. The cube root of 8, we know, is 2. Now, 3 goes into 6 how many times? Is there anything left over? Same answer. Okay. Either way, acceptable. But make sure that if you have this, that you are simplifying it even further. Okay? If you can. Some cases you can't. Okay? Questions? All right, let's look at, try E. Try E. Okay. What do we got? Danielle? 2y to the what? Okay. Anybody else? Sabrine? The 4th root of y to the 3rd, right? Yep. Okay, good. So we have the 4th root, 16y to the 7th. Okay, if we were to rewrite it, 4 through to 16 is 2. Now, 4 goes into 7 how many times? Once. How many are left over? 3. Okay? So, if you had 2 y to the 7/4, we could simplify that. Okay? Where 4 goes into 7 once. So, then you could write it as 2y times y to the 3/4 of what's left over. Okay? These two mean the same thing. Okay? Now, f is the 4th root of 16x. Take care of that first. What is the 4th root of 16? 2. Okay? Can I do anything with the 4th root of x? No, right? However, this whole thing is cubed. So, that means I have to cube the 2 and the x. What is 2 cubed? 8. 4th root of x cubed. Because they're each together through multiplication. So it has to go through. Okay? All right? So again, simplifying with rational exponents, you could go back and forth between radical and rational. Okay? They're interchangeable, so you can go back and forth. Whatever you see fit. Okay? When we are getting, for evaluating purposes, since we are not strong yet with similar bases, or to simplify, let's say, 8 to the 1/3 yet, okay, you might want to rewrite it in radical form first. Okay? So, some properties to remember in terms of simplifying. Okay? We could, with multiplication, if you have the same index, meaning the n is the same, and you're multiplying, it could be written under 1. Same thing with dividing. Okay? So if we recall the square root of 48, if I want to look for the largest square root that's a factor, what would it be? Caitlin? 16. So when I'm simplifying the square root of 48, I'm looking for the highest square root. Square root of 16 is 4 root 3. Or I could simplify using prime factorization, which we just did. What are 2 factors of 48 that come to mind? That's 2 factors we haven't used yet. Yep. 4 and 12, okay? And then I keep breaking this down until I can't go anymore. Okay? So this is a square root. So I'm looking for pairs. So I have a pair of 2's, 1 comes out. I have another pair of 2, another comes out. If something's not circled, stays inside. So I do end up with the same answer. One is looking at perfect roots. One is getting down until you can't go any further. Prime factorization. So the next few you're going to see, which is to Louise's point, are going to be different. They're going to change. How many of a kind are we looking for here? 3. How many of a kind are we looking for here? 6. How about here? 4. So depending on what you're using, you're looking for 3 of a kind. For every 3 of a kind you take out, you multiply together. Whatever's left over, you multiply together. Right? It's the same rules that we use for simplifying radicals, but now the index changes. So we'll do this first one together. 2 factors of 120. Yep. Okay. 40 and 3, and then I could keep going. To what? Keep going. Okay. So I broke this down into prime factorization. Now I'm looking for 3 of a kind. Do you see 3 of a kind? Which is 2. 1, 2, 3. So a 2 comes out. What is left inside? Check. Careful. 15, you have the 3 over here. 5 times 3 is the 15. And if you notice how I wrote my answer, whatever's in the index follows in my answer, if there's something left over. Okay? Do you guys see that? Am I right? Okay. Try 3 and 4. Okay, for the 6th root of 256, what do we have? Taylor, what do you have?
I did not.
Okay. What are 2 factors of 256?
64 and 4.
Okay, 64 and 4. Then we keep going. Okay, so we have 2 and 2. All right, 8 and 8. I'm just going to keep going until I'm in all my prime numbers. Okay, so there's a lot of 2's here. All right, we have a lot of 2's going on here. So how many are we looking for of a kind? 6, right? So I have 1, 2, 3, 4, 5, 6. So I have 6 2's, so 2 comes out. How many are not circled? 2, so 4. This is it. That's it. Good. You explain everything fine. Just looking for a group of 6. That's all. That's the only thing that's different. All right. Some cases that came up in my last class was like, all right, we're looking for, do we count all these or multiply them together? No, you're just looking for a full group of 6 to count as 1, if that makes sense. Okay. How about number 4? What's that? Okay, so we have 3 4th root of 2. So what are 2 factors you used? 81 and 2. Okay. Let me break down. Okay. So again, 4 of a kind, which is 3. Whatever is not circled stays inside. Okay. Any questions? Yeah.
So we have numbers in the root, like the ones that are left over. Do we multiply those numbers?
Yes. Yes. Yep. Good. So whatever you take out, if there's more than 1, you multiply. Whatever you leave in, you multiply. Okay. So then last but not least is we're just going to do a few of these so you guys can get started on some practice of all of this together. Properties of radicals. Okay. What we have in this first one is we're multiplying 3 root 2 times 5 root 8. Now, when you're multiplying and they have the same index, like here and here, you could write it under 1 or multiply those together. So, you can multiply the outside and then the inside. So we have 3 times 5, which is 15, and then 2 times 8. However, what's the square root of 16? 15 times 4? 16. Okay. So again, very similar, very straightforward of what we're used to. Now we have up here. So 2 times negative 3. Negative 6, but then we have the cube root of what? 12. Can we do anything with the cube root of 12? Yeah. Right. We would assume that, right? Looking at it, but now we're looking at the cube root, not the square root, which is different. Typically, we're so used to looking at it, okay, it's the square root, we could simplify, but now our roots are changing, so be careful, okay? Now in number 3, when you have a radical with the same index and you're dividing, you could write it under 1 before you simplify. So you don't have to rationalize or do anything crazy. Here, 24 divided by 6 is what? 4. And then, what is the square root of 4? 3 times 2. 6. Good. Okay, so again, properties of radicals, which we have seen with just square roots. Now the index changes. Okay, I want you guys to look at this last one here. We're going to skip all 1, 2, and 3 and just look at this guy tied together. Okay, this is the 7th root of x to the 8th, y to the 9th, z cubed. Okay, so one way to do this. 7 goes into 8 how many times? How many are left over? 7 goes into 9. How many are left over? Does 7 go into 3? Stays inside. How many of you guys remember that in terms of? A few of you do. Because how many of a kind are we looking for? 7, right? So instead of expanding all these guys out, just do 7 goes into 8, so on and so forth. All right? Okay, I want you to try 4 and 5 to end it. 4 and 5.